Hello, this is the video on plots of functions, and if you stay till the end, you will understand that how the functions behave in terms of their roots and how the rate of change and all that works. So this video I promised in last video, so without further ado, let's get started. So we look at this plot, okay? Now you look at the blue line. Blue line is the plot of y is equal to x. Now you see, it's a linear straight line, okay? So you can very clearly say that from minus infinity to infinity, y always increases, okay? So suppose x is minus 100, okay? Then y is minus 100. If x becomes minus 99, y also becomes minus 99. And so on. When x becomes minus 1, y becomes minus 1. So the difference, if x increases by a difference of 1, y also increases by a difference of 1. If x increases by a difference of 2, y also increases by a difference of 2. So this simple function tells us that it is always increasing. Now, if you want to see the rate of increment is given by delta y by delta x. So suppose x is 0, then y is 0. And if x is 1, y is also 1. So you do the delta y, 1 minus 0, and delta x would be delta x would be 1 minus 0. So delta y by delta x is equal to 1. That is for that segment. Now from the perspective of calculus, if you differentiate this function, you get dy by dx is equal to 1. And therefore, we can say that the rate of change is a constant, that is 1. And that's what we have proven, that delta y by delta x will always be 1. If you increase x by 2 and then y also increases by 2. So delta y by delta x is equal to 2 by 2. And that is again 1. So rate of change is constant, and that is 1. And since it is positive, if you look at rate of constant, it is positive, and therefore it will always increase. So it is called monotonically increasing function. Now we look at two parabolas, or rather three parabolas. The first, or quadratic equation. When we talk of parabolas, it is quadratic equation. So first equation is y is equal to x plus 1 into x plus 2. Second is x minus 1 into x minus 2, and third is y is equal to x square. So if you look at first equation, it is x plus 1 into x plus 2, that is x square plus 3x plus 2. So if you look at this red curve, the light red, or rather bright red, if you look at this bright red curve, then you see it cuts the x-axis as minus 2 and minus 1. That means at these two values, the value of y will be 0. So these are also called roots. Where the curve will cut the x-axis, that x coordinate is called the root. Similarly, for y is equal to x minus 1 into x minus 2, if you look at this equation, it would be x square minus 3x plus 2. So that is your green line, okay? So if you see your green curve, it cuts at minus 1 and minus 2. If you look at y is equal to x square, it has repeated roots. I'm talking about the dark red color. So now if you look at y is equal to x square, it only touches at x is equal to 0. That is, it has repeated roots because only one point it touches. Now let's say we differentiate y is equal to x square. So dy by dx is equal to minus 2 of x. Now you see, 2 of x, y is equal to 2 of x. Now you see, dy by dx is equal to 2x. When you look at this, that is the rate of change. So you can plug in some values and you can find delta y and delta x. So let's say that our delta x we want to compute, and x is equal to, we take two values, 0 and 1, for or rather 0 and 1 will do. So our delta x is 1 minus 0, okay? Now delta y, if you look at delta y, then y would be 1 minus 0. So the rate of change between this segment on average is 1. But if you increase x to say 0 to 2, then what happens is that your delta x becomes 2, but delta y becomes 4. So you see, y is changing in terms of x square. If x changes by amount k, y will change by amount k square. Alright? So similarly, if you want to find the rate of change at any point of time, you compute the derivative. So dy by dx would be 2x. Now this 2x implies that when x is negative, rate of change is negative. So if you draw tangents at these lines, the slope, that is the angle made by those lines on the left side from the y-axis, the slope of the lines will be greater than 90 degree. But if you plot the same tangents on the right side, the slope of those lines, that is angle made with positive direction of x-axis, would be your positive, or rather 0 to 90 degree. So tan theta of 0 to 90 would be positive, but on the left side of x-axis, the tangents will be negative. So that's how the rate of change works. So we cannot say that y is equal to x square is monotonically increasing, but for positive values of x, we can say that it is monotonically increasing. And we can say that for negative values of x, it is monotonically decreasing. Now, similarly, we look at a cubic, and before looking at the cubic equation, let's look at these equations, okay? Now, you see that y is equal to x square is touching the x-axis, but if we add, let's say, a positive quantity k, let's say we add 1, then what will happen? The entire dark red color curve will go up by 1, and then it won't touch x-axis anymore. And if y is equal to x square plus 1, then the equivalent quadratic equation will be x square plus 1 is equal to 0. That is, roots would be square root of minus 1. That means the roots are now plus minus I, or complex conjugate. And when that is the case, those roots you can't see them in the xy plane, because those will lie in complex plane. We can't see them here. Alright? So it won't touch the x-axis. That's how we know that roots are complex, that it won't cut the x-axis as such. Now another cubic equation, if you see, now if you look at this cubic equation, it is x minus 3 into x minus 6 into x minus 20. So it has 3 roots at 3 and 6 and 20. So you see, it will change sign. So before this point, somewhere around 6, because if you draw a tangent at 6, it would be parallel to x-axis. So before that, it is increasing in nature. Okay. Between x is equal to 6 to somewhere around 15.5 or 16, it is decreasing in nature. And then after that, it increases all the way. Now, if you look at this graph and you figure that if you shift this graph by, let's say, 500 units, okay, you say y is equal to x minus 3 into x minus 6 into x minus 20 plus 500. Then this entire graph will shift up by 500 units, okay? And then it will cut only at one point, somewhere around here, or rather left to this, alright? It will no longer cut at 3 points. So what happened? If you shift it up by 500 units on y side, then the roots, 2 roots, which are real, that is this root 6 and 20, they will go into complex plane. So there will be complex conjugate roots and they won't appear anymore in this. Now, how many times fx changed sign? Okay. So fx was, if you look at f dash x, so f dash x changed once here and once here. So 2 times fx changed. So sign change will be, there will be 3 possible rate of changes. Okay. So 2 will be positive and 1 will be negative. So I think I explained quite a bit here in this video, and I hope that you find it useful and informative for the problems on polynomials and theory of equations. I will end this video here, and if you have comments or if you have questions, then let me know by using the comment box. And in the next video, I'll see you when we will discuss 10 more problems on polynomials and theory of equations. So thanks a lot for watching the video. I hope that you are working hard, which is very important for your studies and exams. So I'll see you in the next one. Till then, sayonara.